Hello, my name is Victor. I'm a secondary school maths and science teacher. I'm currently based in Hanoi. I come from a mechanical engineering background, and this has shaped the way I view maths, especially as an educator. I used to view maths strictly as a tool for solving problems. That being said, over the course of my clinical practice, my mindset and as well of that of my students have shifted significantly, from using maths as just a problem solving tool to using maths as a way to express yourself, you know, um, in our daily lives. We're beginning to see instances and situations where we can use maths to express ourselves accurately, to accurately express our feelings, and how we can interpret mathematical concepts into day-to-day life. In module 4 of my course, we dabbled into UDL, Universal Design for Learning, and inquiry-based learning. And this has sharpened how I approach maths education. At first, I assumed that universal design for learning as well as differentiation meant reducing the rigor of the questions, or of the problems, whatever the case might be. Um, However, I couldn't be more wrong, right? Because when you design your lessons for diverse profiles of students, you have multiple entry levels, and you afford your students the opportunity to learn the same thing using different models, if I so to say. So take for example, you're teaching adding mixed numbers, right? Initially, I'll teach the students the maths knowledge, how to change a mixed number to an improper fraction, and then sum the improper fractions, and then convert back to a mixed number, and you know, something similar to this. However, now I teach the maths knowledge, and then I also offer lots of visual representation. So we have 3 1/4, for example. So I'll draw 3 balls to show the whole part, and the fourth ball would be cut into 4 and 1 part colored. And now the students can visualize 3 whole and 1/4. And if the sum gives us something, if when we sum the fractional part, for example, and the answer becomes an improper fraction, it's easier for the students to see and understand that these two fractions, sum up to an improper fraction, and it's more than one. Now they can understand why an improper fraction is always more than one. It makes a lot more sense. They can, grasp it easily. Compared to when I was just delivering my classes as though they were lectures. Because my class consists of a lot of ESL learners who more like struggle with the wording of the problems and not just the maths skills itself. They find it difficult to decompose the questions, break it down into chunks. And so I believe I've started learning or developing skills on how to scaffold questions like this, without reducing the rigor. The I do, we do, and you do, the gradual release framework is something I utilize a lot because it helps students build on their confidence. Sometimes I could use diagrams, equations, tables, and whatnot to represent the same question so students can see that we have the same problem, but this problem can and could be solved using a diverse range of approaches. And this has been one of my biggest takeaways. Um, Initially, when I began applying scaffolding, and allowing students to demonstrate understanding through different models, sometimes I can allow them to do calculations, sometimes draw a picture or a table. Sometimes I even go as far as send me a coding sample because my students spend most of them are fluent in Python, so and I also I'm also fluent in Python. So sometimes I'm okay, you know what? Give me your response as a Python script, and I'll run it and see what it gives me, right? Um, it brought out the engineer in me because I now treated the classroom like it's a lab where different builders can use whatever tools they are more comfortable with to express their ideas. So it's not always this is a list of what you must do. I have an idea of where I need them to arrive, and I let them arrive there, using whatever route seems, whatever route they're most comfortable with. The most important thing is to always make sure that we achieve the objective of the lesson. And there's no set way, for example, to say you must always take this step, that step, and that step. I've learned that the freedom and the choice of learning, should be returned back to the students, and that's when they actually shine. I mean, it goes without saying, my students had always believed that you're born with math ability, it's either you know it or you don't know it. So usually when I met them at first, they pointed a couple of students and I teacher, these students are the best students in math class, in our class. The rest of us were just, we're just okay students. But towards the end of the year, I'm beginning to see a lot more students ask intriguing questions in class, and that's one of my proudest moments because I have some students who are a little bit too conscious of making mistakes, for example, and I've begun to see these students, volunteer on their own to solve problems, knowing that making a mistake is part of the learning process. It's not a nail on the cross, so to say. If you miss a question, now we understand and we value more than the correct answer, the journey towards the answer, right? It's not always about getting the right answer, but more about what you're thinking behind, what's your reasoning, what's the first thing that comes to your mind when you see a question like this, what's the first thing you think of, what does this make you remember? So we've begun to reason more and think about why we do certain things, Say, for example, we have a two-step equation. Why would you add first instead of dividing, right? Why would you carry out this step? Okay, you know this is the right step, but why would you do this? So we have begun to ask the whys in the class, and this has unlocked a lot of potential because when you probe further, students who might have had some misconceptions, but wouldn't be so bold enough, so to say, to ask for clarifications, begin to get clarifications, towards these misconceptions, and it helps to boost their confidence. Sometimes they might know the answer, but they wouldn't be so bold enough as to volunteer to answer. So when the very bold ones answer the question and we probe further, we get a lot more engagement because this student now says, okay, my answer is correct. Now maybe I can share why I did what I did and how I did that. So I really appreciate my students for taking out their time, so to say, and for being a lot more courageous. Right. So to sum everything up, my program has transitioned me from an educator who just, follows a set of instructions. I've transitioned from an engineer who just teaches maths, precision and accuracy. You have to be precise, you have to be fast, you have to do this, into an educator who engineers maths experience. And in one of our classes, we had a debate, and this is something that was new to the students, transforming the equation into real life scenarios and making the equations make sense to us, in a in a day-to-day context, in a daily context, in things that we experience in our daily lives. And I think my students really appreciate that, and I will continue to develop myself because I believe that as educators, we owe it to our students who are shaping their lives, to make sure that we are, as much as possible, the best versions of ourselves. Thank you.